In this video, we're going to continue our work with quadratic equations and look at the quadratic formula. To begin with, I'm going to look at some different types of quadratic equations. I'm going to split the page up into three, and the first type we'll consider are of the form ax squared is equal to b. When we have this form, as we saw in the first video, we can simply square root both sides of the equation. So for example, if we had x squared is equal to 25, we would square root both sides of this equation, and we could say that x is equal to plus or minus the square root of 25, which gives us plus or minus 5. I certainly wouldn't use the quadratic formula for this particular equation. If we had, for example, 2x squared minus 72 is equal to 0, again, I wouldn't use the quadratic formula. I would simply add 72 to both sides. So we'd have 2x squared is equal to 72. Divide both sides by 2. X squared is 36. And take the square root of both sides. X is equal to plus or minus the square root of 36, which is going to give us plus or minus 6. So if we simply need to square root both sides of the equation, we wouldn't use the quadratic formula. We're now going to look at the form ax squared plus bx is equal to 0. An example could be x squared plus 4x is equal to 0. If I wanted to solve this equation, again, I wouldn't use the quadratic formula. I'd look to go ahead and factor this. Taking a common factor of x out, we'd have x, and then we'd have x plus 4, and that's equal to 0. So x would be equal to 0, or x would be equal to negative 4. We saw this type in the first video. So ax squared plus bx is equal to 0. Now let's look at the form ax squared plus bx plus c is equal to 0. So this time we have a constant. If we can factor these particular equations to solve, then it's a lot easier to factor than substitute into the quadratic equation. So for example, if I had x squared minus x minus 12 is equal to 0, this is in the form ax squared plus bx plus c is equal to 0, and this will factor. We'll have x minus 4 multiplied by x plus 3, and that will be equal to 0. So from the skills we learned in the first video, we can see that x would be equal to 4 or x would be equal to negative 3. So if we can factor, we always go for that method as it's significantly easier to factor than it is to mess about with the quadratic equation or quadratic formula. So if we have a scenario where a quadratic won't factor, we've got two choices. The first one is to complete the square, which we saw in the last video, and the second is to use the quadratic formula. So let's say I had now, we'll go for 2x squared, then we'll have now plus, and we'll go for 3x, and then we will have now on here, we will go for minus, and we'll go for minus 4 is equal to 0. So I can look at this, 2 times by negative 4 is negative 8. I can't find two numbers, but multiply to give negative 8 and add to give positive 3. So this one wouldn't factor. I could complete the square by dividing through by 2, as we saw in the last video, and completing the square. What we're going to do though is look at the quadratic formula when we have a quadratic in the form ax squared plus bx plus c is equal to 0. So if our quadratic can be written as ax squared plus bx plus c is equal to 0, the solutions will be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is what we use, and in most formula books it's given. So let's just consider this quadratic. It's in the form that we want, so all we're going to do is simply substitute in the values. So a is going to be equal to positive 2, b is going to be equal to positive 3, and c is going to be equal to negative 4. we need to be careful with the signs. So I'm going to solve this particular quadratic equation using the quadratic formula, which is this just here. So we can say that x is equal to negative b. Well, b is 3, so that's going to be negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 lots of a, which is going to be 2, multiplied by c, which is going to be negative 4. And that is all over 2 lots of a, which is going to be 2 lots of 2. This should lead to what we call an exact answer. So we can leave it in surd form. You might be asked to round to 3 significant figures or 2 decimal places, for example, but generally speaking, we could leave this in exact form. So x is equal to negative 3 plus or minus the square root. So if we look at this, this is going to give me now on here 9. Then we're going to subtract from here. 2 times 16 is 32. We've got 2 negatives. So that's going to be 32 plus 9, which is going to be the root of 41. And that's all over 4. So all I've done is just tidied this up. And this is exact form. We got negative 3 plus or minus root 41 over 4. We could have done this in a calculator. All we do is set up the fraction bar. We put in now negative b, so that'll be negative 3. I'll start with the plus, the square root of 3 squared, which is 9, minus 4 lots of a, which is 4 lots of 2, multiplied by c, which is the negative 4. And that's all going to be over 2 lots of a. 2 lots of a is going to be 4. And we'll see that that is the answer we get. Negative 3 plus root 41 over 4, which is about 0.851. I can then get the second solution by substituting now the positive for a negative, and that gives us now about negative 2.35. So this is exact form, and this is the decimal form. We can simply sub it in. Now here you could have put the multiplication signs. It's entirely up to you. So, if you want a bit of confidence to check that this works, if we take this one just here, it's in the correct form, ax squared plus bx plus c. Well, a is going to be equal to 1. We've got b equal to negative 1. And we've got c equal to negative 12. So we can say the solutions, x will be equal to negative b, which will be negative negative 1. So that will be 1, just positive 1, plus or minus the square root of b squared, negative 1 squared is 1, minus 4 times by a, times by c, and that's all over 2 lots of a, which is going to be 2 lots of 1, which is just going to give us 2. So we can see this is going to be 1 plus or minus the square root. Now this is going to give me here 48. 1 plus 48 is going to be 49, and that is over 2. So we get on here now 1 plus or minus the square root of 49, which is 7 over 2. So we can see 1 plus 7 over 2. So 1 plus 7 over 2 is equal now to 4. Then 1 minus 7 over 2. 1 minus the 7 over 2. Well, that's going to give me now negative 3. And if we look at that just there, exactly what we expected. So that is how we could use a quadratic equation. As you can see though, if it factors, go ahead and do it. You can complete the square if you prefer to do that. I actually prefer completing the square, but it's entirely up to you. So on this one, if we completed the square, 2x squared plus 3x, and then we had, was it minus 4, and that's equal to 0. Let's just check that. That looks good. Then I would divide through by 2, so we'd have x squared plus 3 over 2x minus the 2 is equal to 0. Completing the square, x plus 3 over 4, all squared, minus 9 over 16. Then we're going to have on here minus, and I'm going to put this over 16, 32 over 16. That's equal to 0. X plus 3 over 4, all squared, is equal to 41 over 16. Taking the square root of both sides, x plus 3 over 4 is equal to plus or minus root 41 over 4. So subtracting the 3/4 from both sides, x is equal to negative 3 plus or minus the square root of 41 over 4. So as you can see, exactly the same solutions we've got here. It's just an alternative way of doing it. So there we go, that's the quadratic formula. As stated, all you need to do is identify A, B and C, make sure you've got the correct values, rearrange if applicable, and then substitute in. Okay, so we've seen now that the solutions x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can say that if a quadratic is in the form ax squared plus bx plus c is equal to 0, this will find us the solutions. We'll consider when we have no real solutions in the videos on the discriminant. For now, all I'm going to do is show how we derive this formula from completing the square. So this part of the video is included for completeness and a bit of an extension, but I think it's interesting nonetheless. So what I'm going to do is solve this quadratic equation to form the quadratic formula by completing the square on this. So if I want to complete the square, I need to make the coefficient of the term in x squared 1. So at this stage, I'm going to divide through by a. That will give me x squared plus b over ax plus c over a is equal to 0. I'm now going to complete the square on the x squared plus b over ax part. So I'll have x plus half this quantity, which is b over 2a. We need to square this and subtract away this value squared, which will be minus now the b squared over this quantity squared, which is going to be 4a squared. And then we will now go ahead and add the c over a, and that will be equal to 0. At this stage, I'm just going to write this as an equivalent fraction just here. So we've got x plus b over 2a all squared minus b squared over 4a squared plus. Now if we think about this right here, if I want now a common denominator, I've got 4a squared and I've got a. To get a common denominator, I'm going to have to multiply this by 4a. So if I multiply the numerator by 4a and the denominator by 4a, we will have an equivalent fraction. And that will give me 4ac over 4a squared, and that's equal to 0. I'm now going to add this quantity and subtract this quantity from both sides and combine the fraction. So we've got x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. Taking the square root of both sides, x plus b over 2a will be equal to plus or minus the square root of b squared minus 4ac over now the square root of 4a squared, which is just going to give me 2a. I'm now going to subtract this quantity from both sides, and we'll see that x is going to be equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. All we'd need to do is finish this off, is just combine this as a single simplified fraction, and we can see that we can derive the quadratic formula from completing the square on ax squared plus bx plus c is equal to 0. So as stated, that's just included for some sort of completeness or understanding, and that's how we can derive the quadratic formula. All we're going to do in this video is look at some basic examples of using the quadratic formula. So in question 12, we're asked to use the quadratic formula to find the solutions to the following equations. We're asked to give our answers in exact form. So if I can give them in exact form, I'll give them in exact form. If not, I'll just go ahead and round them. So let's look at this one. Is this in the form ax squared plus bx plus c is equal to 0? Yes, it is. So we can see that a is going to be equal to 1, b is going to be equal to negative 3, and c is going to be equal to negative 8. So using the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to have now that x is equal to negative b. Well, that's going to be 3. plus or minus the square root of negative 3 squared, which is 9, minus 4 lots of a, well a is 1, multiplied by c, which is going to be negative 8, all over 2 lots of 1, 2 lots of a, which is 2. I'm simply substituting in. So from here we can see this is going to be 3 plus or minus the square root. That again here is going to give me 4 times by 8 is going to be 32. 9 plus 32 again is going to give me the 41, and that is going to be over 2. So it's 3 plus or minus the square root of 41 over 2. 41 is a prime number, so we can't simplify that. If we just want to go ahead and check that, we've got 3 plus the square root of 3 squared, or negative 3 squared. Remember, square and a negative just gives us a positive. Minus 4 lots of a, well a is going to be 1, multiplied by c, which is negative 8, all over 2 lots of a. 2 lots of a is 2, and that gives us 3 plus root 41 over 2. All we need to do is switch this over. 3 minus root 41 over 2. So negative 1.70 to 3 significant figures, and if you wanted to check the previous one, the plus answer, then we're going to get 4.70 correct to 3 significant figures. Okay, let's deal with this one right here. So this is b. So we've got 2 minus 10x plus x squared. I'm just going to rewrite this as x squared minus 10x plus 2 is equal to 0. So that's in the form ax squared plus bx plus c is equal to 0. A is going to be equal to 1. B is going to be equal to negative 10. And c is going to be equal to positive 2. So simply substituting in here, all we'll get now is that x will be equal to negative b. Well, that's going to give me positive 10 plus or minus the square root of negative 10 squared, which is 100, minus 4 lots of a is 1, c is going to be 2, and that's all over 2 lots of 1, which is going to give me 2. If you want to put 2 lots of 1 in, you can do. Okay, so if we just do a bit of simplifying, what we've got here, 10 over 2, I'll simplify it as we go through, in fact. So what's that going to be? That's going to be 10, let's write this in, 10 plus or minus the root of, what are we going to have, 92 here. So 92, and that's all going to be over 2. So if we just consider the root of 92, then 92 is going to, let's just look at that. That's going to be 2 times 2 times 23. 23 times by 2 is 46, times by 2 is going to give me 92. So we could simplify this, and remember this unit is non-calculator. We're going to get 2 root 23 over 2. Simplifying further, x is going to be 5 plus or minus the square root of 23. So all I've done is simplified. Let's check that on a calculator to make sure that I've got that correct. So what we've got then is negative b, so that's going to be 10 plus the square root of 100 minus 4 times by a, which is going to give 1, don't really need to put that in, multiplied by c, which is going to give 2, all over 2 lots of a, which is going to be 2 lots of 1, that's 2. So it's 5 plus root 23, and then of course we'll get 5 minus root 23. This is where I much prefer to complete the square. If I completed the square here, x minus 5, all squared, minus 25 plus 2 is equal to 0. X minus 5, all squared, is equal to 23. X minus 5 is equal to plus or minus root 23, and x is equal to 5 plus or minus root 23. So if you saw the last video, it makes a lot more sense for me to use this particular method, as it's a nice quadratic. Okay, let's look at the next one. So it's in the correct form, ax squared plus bx plus c is equal to 0. So a is going to be equal to 3, b is going to be equal to negative 2, and c is going to be equal to negative 4. So substituting in, x is going to be equal to negative b, so that's going to be 2, plus or minus the square root of b squared, which is going to give me 4, minus 4 lots of a, which is going to give me 3, multiplied by the 4, all over 2 lots of a, so that's 2 lots of 3. Okay, so x is going to be equal to 2 plus or minus the square root. So if we just consider this, this is going to give me now on here 52. 4 times 4 is 16, times by 3 is 48. So it's going to be 52, and that's all over 6. If we think about now 52, 52 is going to be 2 times by 26. So that's 2 times 2 times 13. So we could write x is equal to 2 plus or minus 2 root 13 over 6. So we can see x is going to be equal to, now we could write this as 1 plus or minus root 13 over 3. Again, let's just check that. Substituting in the values, we'll have now 2 plus the square root of 2 squared, which is 4, minus 4 times by a times by the c, which is a negative 4, and that's all over 2 lots of a. 2 lots of a is going to give me 6, and we can see 1 plus root 13 over 3, and of course if we just switch this over, it's going to be 1 minus the root 13 over 3. Right, if we look at D, now on here, this is in the correct form, ax squared plus bx plus c is equal to 0. What we could do here is write that a is equal to negative 1, b is equal to positive 7, and c is going to be equal to negative 1. I would prefer to just add now the x squared, subtract the 7x and add the 1 to both sides, and write this now as x squared minus 7x plus 1 is equal to 0. This gives me a is 1, b is equal to negative 7, and c is equal to positive 1. I think it makes my life slightly easier. All that's happening here, and if I just draw, what we would have is the negative equivalent of the parabola. So let's say we looked at the first one. The first one is a negative. Let's just draw some negative quadratic. This isn't necessarily this one just here. And then I drew the other one, the positive. What we're going to have is something that looks like that. The points of intersection here are going to be identical, so it doesn't matter that I've swapped the sides. I think it just makes my life slightly easier. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is going to be equal to negative 7, so that's going to be 7 plus or minus the square root of b squared, which is 49, minus 4 times by a multiplied by c, all over now 2 lots of a, which is going to be 2 lots of 1. So x is going to be equal to 7 plus or minus. Well, this is going to give us now 49 minus 4, which is going to give us root 45, which we can simplify, and that's all over 2. X is going to be equal to 7 plus or minus. This gives us 3 root 5 over 2, and that's what we have. Okay, if I completed the square, x minus 7 over 2, all squared, minus this value squared, which is going to be 49 over 4. Then we're going to have plus a 1, which is going to give me 4 over 4, and that's equal to 0. So x minus 7 over 2, all squared, is equal to 45 over 4, by adding this to both sides. Taking the square root of both sides, x minus 7 over 2 all squared is equal to plus or minus the square root of 45, which is 3 root 5, over the square root of 4, which is 2. So we can see now, from here, let's just get rid of that square. We've already done that. That's what we should have. Could get rid of the brackets as well. Just adding the 7 over 2 to both sides. 7 plus or minus now 3 root 5 over 2 will give us these solutions. So that's completing the square. Okay, let's look at this one. Let's do some rearranging. So if we rearrange this one in the form ax squared plus bx plus c is equal to 0, we've got 7x squared minus 5x minus the 1 is equal to 0. A is equal to 7, b is equal to negative 5, c is equal to negative 1. So x is equal to negative b, which is going to be 5, plus or minus the square root of b squared, which is 25, minus 4 lots of a, which is going to be 7, multiplied by c, which is negative 1, all over 2 lots of a, which is going to be 7. So x is going to be equal to 5 plus or minus. If we look at this, that's 28, which is going to give us 53, and that's all over 14. Can we simplify root of 53. Doesn't look like we can. So let's check that on a calculator. So what we've got then is 5 plus the square root of 25 minus 4 times by a, which is 7, multiplied now by c, which is -1, and this is all over 2 lots of a, which is going to give me 14, and I think this is in simplified form, and there we go. 5 plus or minus root 53 over 14. Okay, let's look at the last one. I think I'm going to struggle to put this in exact form. I suppose I could if I took my time. But the first thing we need to do is just rearrange this. So we got 1.2x squared. Then we got plus 0.3x. And then we got minus 2.5, and that's equal to 0. I'm just going to use a calculator for this one rather than trying to put it in exact form. So a is going to be 1.2. B is going to be 0.3 and C is going to be -2.5. So just be careful on here in terms of rearranging, and we'll sub that into the calculator. So what we'll have is negative b, so it'll be -0.3 plus the square root of b squared. Let's put there we go, b squared, which is going to be 0.3 squared, which is 0.09, minus now 4 lots of a, which is going to be the 1.2, multiplied by the c, which is going to be the -2.5, and that's all over 2 lots of a. 2 lots of a is going to give me 2.4, and we end up with 1.32. So x is equal to 1.32, and I'm giving these to 3 significant figures, and then we simply switch over now, and we will get on the next one when we -1.57. X is equal to -1.57. Again, 3 significant figures. So there we go, using the quadratic equation. So if it looks like you can square root it, square root it. If it looks like you can factor it, factor it. If you want to complete the square, you can do. I would only ever use this if I couldn't complete the square, or it needed specific answers to decimal places where I was going to put it in a calculator. Otherwise, I'd look to put it in exact form, either by factoring or completing the square. So in the next couple of videos, we will look at some more challenging questions that involve quadratic equations.